So we are going to integrate B dot dl. Okay, so dl, so we will integrate on both the sides. So integrating here and integrating here, constants you take it out, and we are going to integrate only d theta. Okay, clear up to this? So while doing that, we will have what? D theta is theta. Okay, so theta, and we are just taking as mu naught. This is all constant, so I am taking only mu naught I. Okay, for second path also we will get the same thing, because they are considering one in the diagram. You maybe got to know that one path is AB, the another path is BC, like that. So that's why we are having like theta AB, theta CD and all. Okay, so those element is a radial elements such as BC or 0 perpendicular to all these segments. So if you see the diagram, you will know the entire path how it is. Again I will show you. See, so small path on the DL they are separating. Okay, so to AB, CD, like that. Okay, small path I am considering. So total will be, we will add together, summation, correct? So that's what here happening. Okay, clear? Now it is clear for you? Okay, for all the segments it will be perpendicular. Okay, so to entire path, so we will add everything. So now theta AB plus theta CD. Okay, so now from this you will get mu naught I. So theta, that is half circle, next half circle. So full circle, we will have theta value is 2 pi. Okay, so 2 pi will get cancelled, and you only will get mu naught I times. So thus we prove the Ampere circular law with this. Okay, so we are just proving this Ampere circular law is mu naught times of I. Okay, so in Gauss law also we will have a proof, right? So in circular integration we will get Q by epsilon naught times. Correct. The same way here also we are proving with the segments of the part thing, and we are integrating to get the whole thing. So in a closed loop we are telling it is mu naught times of I to get the magnetic field in that path B dot dl. Clear? Yes. From the beginning. Okay, so the definition is the first one. Okay, so this is the definition of Ampere circular law. this formula you got, do you remember in previous derivations we did with cos theta, b dl cos theta we did, and we find this. If it is a radian, that means taking an angle theta, so this will become only r you will see, I guess, right? So here we are adding d theta because we are considering an angle also. Okay. We are comparing those two equations with b dl. Okay, then we integrating it. Okay, so both the sides we are integrating. Here only, right? Yes, we cancelled here. There also you can do, but while integrating we are doing it anyway. Okay, shall I go to the next one? So that's so you are getting like this, mu naught I. For path 2 also, for arc we are getting AB arc. So bit by bit we are taking as a arc, so together it will make us a circle. Okay, that's why we are taking last two first.